Hello class, what's up is Raj here. So today we are discussing about the class 9 chapter 1 matter in surroundings. Okay. In this chapter we are learning the concepts very simple, structure, easy to revise and the copy friendly. You can write it down in examination also. So what is a matter class? If we're talking about the matter anything that has mass and occupies space, anything that has a mass and occupies a space. For example, if we taking example of this bottle has a mass and occupies a space, you can see that there is a space occupied by this bottle. So these including are there. After that, what is the example of it? Air, water, stone, smoke are the example of the matter. So next topic class, particle nature of matter. What do you mean the particle nature of matter? Matter is the made up of the teeny particles. Okay, the teeny particles including in the matter are there. And what is the characteristic of it? The very small particles, space between the particles, continuous motion including are there, force of attraction exists. So very small particles, spaces between the particles, continuous motions and the force of attraction are exist in the particles nature of the matter including are there. When we're talking about the state of matter, what do you mean by it class? That is a solid. Solid has a fixed shape and the volume. For example, if we taking example, this is called solid class. This is an example of the pen are there. So these have the fixed shape, volumes, and the particles of these are tightly packed, strong force of attraction including are there, and not compressible. You can't compressible easily these things. So these things are come under in the solid. Next we're talking about class liquid. What am I the liquid class? Fixed volume, no fixed shape. For example, you're taking example of water are there. Particles are the loosely packed, moderate attractions, and the can flow easily. Okay. Next, if we're talking about the gas, no fixed shape and volume. For example, if you're taking, we know that the humans are taking oxygen and releasing carbon dioxide. So in these things you can see that class no fixed shape and the volume of the gas are there and the particles are very far apart. So for example, one molecules are there, one molecules are there. So there is a far distance between them. Weak attraction, we know that if the distance is thus far, so that weak attractions including are there, but highly compressible. These things are the highly compressible. Other state also we are talking about plasma, ionized gas and including are there, and BEC, very low temperature state class. So interconversion of state depends upon the temperature and pressure. When the applied the temperature on the particular solid that converted into the liquid and applied temperature on it liquid that also converted in the gas. So there is an interconversion of gas that dependent upon the temperature are there. So pressure is also including are there. How? If you increase the pressure, that also compressible these things. Okay, you can compress the gas in a liquid and the liquid in a solid are there. So what types of changes? You can see solid, liquid and gas, melting, solid to liquid, boiling, liquid to gas, condensation, gas to liquid, and freezing, liquid to solid. So these changes are including to changing the state from one state to another state of the particles are there. Next, sublimation. If we're talking about the sublimation class, the solid is the gases directly. For example, camphor, ammonium chloride, including in the sublimation. So these are come under in the sublimation. If you're talking about the class latent heat, what do you mean the hidden heat during change of state? Okay. So you know that class, the latent heat including the hidden heat in the change of state, and there is an example of it class the fusion and evaporation. You can see that in fusion there is a conversion of solid to liquid, but in a case of vaporization the liquid is converted to the gas. So in both things we can see that there is a latent heat including up there in the form of the hidden heat during the change of state in simply concepts. Next, evaporation. If you're talking about class evaporation, so liquid is converted into the vapor below the boiling point and the surface phenomenon including in the evaporation. So we knowing that class there is a changes of state in including are there. For example, evaporation, accountability of the heat including are there. Next, factors. If you're talking about the factors class, there is a surface area. Is the surface area increasing class? The rate is also increasing. and the temperature also increasing, rate is also increasing, and the humidity also increasing, rate is also increasing. So there is a wind speed. If the wind speed also increasing, rate is also increasing. So these are the factors that are directly proportional to each other and also the inversely proportional to each other. But we can say that the surface area increasing, the rate is also increasing, the temperature increasing, rate is also increasing, humidity also increasing, the rate is decreasing. Okay, and wind speed increasing, the rate is also increasing. So only one concept, the one exception about the humidity, when the humidity increasing, rate is decreasing. Okay, I although all these things are the same. Next, cooling effect. What do you mean by the cooling effect, class? Evaporation absorb heat. Evaporation absorb heat, and the heat is going to the cooling. So you can know that, you can say that there is a cooling effect of the evaporation absorb the heat to cooling. So these are including are there. After that, what is the difference between the evaporation versus boiling? So evaporation, there is a surface, slow, and any temperature including the evaporation. If you're talking about the boiling, there is a whole liquid, fast, and the fixed temperature including in the boiling. So you can say that, class, in the simple manner of form. Evaporation, there is a surface, slow, and any temperature including in the evaporation. In the boiling, the whole liquid, fast, and the fixed temperature including in the boiling. So next, you know that, class, the temperature scale. So there is a Kelvin, that is the SI unit including are there, that denoted by the T, and the Kelvin including are there, and after that the degree Celsius including in this T. So you can say there is a 273 degree, that is also including are there in the form of adding. If you want to change degree Celsius to the Kelvin, you can add 273 into the degree. For example, 27 degree, you have to change in Kelvin scale. How do you can change? 27 plus 273. Okay, so there is a, in Kelvin scale, 300K is the answer. You can add both these things. And what is the important? 0 degree equals to 273K, and 100 degree Celsius equal to 373K. Okay, quick revision. Matter is equal to mass plus space. Okay, three state: solid, liquid, and gas. Sublimation, direct change. Okay, and evaporation causing cooling. Okay, and next, Kelvin is a SI unit. So these things are including are there. Thank you.